Hi everyone, this is the 4.1 Part 1 Ready, Set, Go notes. So you should be following along in your packet and taking notes, and then make sure you come to class ready to ask any questions if you're confused on anything. So first thing we are going to talk about in this is we're going to define what an expression is. So mathematical representation made using numbers, variables, and symbols. So that's what an expression is. So we've talked a lot about equations, and we touched briefly in class about the difference between an expression and an equation. An expression is really just part of an equation. The equation is what actually has the equal sign. So an example of an expression could be something as simple as 2x, or it could be something like 3x minus 7, or it could even be something that's more complicated, 2 times x plus 3 minus 8. So all three of those are three separate expressions. So we're going to talk about how to actually build our own expressions. So we've done it a little bit in the task. So here's our actions, and we're going to write the symbolic representations so that we can find the total number of students in the club. So part A says the number of students that bought pizzas. So we're going to go ahead and call that X. Part B says after the second week, the number of students that bought pizzas increased by 10. So if we know that we had X number of people who bought pizzas originally, and it increased by 10, that word increased means that we've added. So we're actually going to add 10 to what we originally had. Then the next part says after the third week, the number of students who bought pizza tripled. So hopefully you guys look at that and you know that the word tripled means that it's multiplied by 3. So what we're going to do is 3 times the number of pizzas that were already sold. So we know that the number of pizzas already sold was this quantity up here, which is that x plus 10. Then it says in week 4, the number of students who bought pizza was decreased by 9. So that's going to be important, and we should know that the word decreased means we're subtracting. So we're going to take whatever it is we had and end up subtracting 9. So we want to have the rest of the original, which was 3 times the quantity of x plus 10, and then we're going to subtract 9. So really, you want to be able to pick out those key words. So increased meant we were adding, tripled meant we were multiplying by 3, and decreased meant that we were subtracting 9. So those are the key words that you want to look for when we're writing these expressions. Okay, next part is talking about simplifying different expressions. So you'll notice all three of these things down here, they have their expressions, they do not have an equal sign. So all we can do is simplify them. The first thing we can try is distributing, which we've done before. We know that distribute means take whatever is in front of the parentheses and we're going to multiply it inside. So we're going to do 3 times x and we get 3x, 3 times negative 4 and we get negative 12. Then on that one, that's it. There's nothing else to be done there. By distributing, we got rid of the parentheses and there's nothing else to do. So we're just done there. The second thing we can try is combining like terms. So we've done this before also. Like terms mean they have to have the same variable, same exponent, or they have to both just be numbers. So here we have a 4x and a 5x. If we put those together, we're going to add that and get 9x. And then we can also see that there's a negative 7 and a positive 2. Both of those are what we call constants, right? They're just numbers. So if we add those together, negative 7 plus 2 gives us a negative 5. So when we combine like terms, we made it smaller, we made it simpler by putting the like ones together. So remember, when we add like terms, or combine like terms, it means that we're adding them together. So we did 4 plus 5 and negative 7 plus 2. That's how we got to our final answer here. The new thing that we could do that we didn't talk about yet is we can also divide in order to simplify these expressions. So when we look at this one, 15x minus 20 over 5. since this whole fraction is being divided, or this whole numerator is being divided by 5, we can actually split it up, and we can make it 15x over 5 minus 20 over 5. So we took the first part and made it over 5, the second part and made it over 5, and since there was a subtraction sign right there, we're going to leave that subtraction sign right there. But now we can actually see that that simplifies down. So 15x over 5 is actually 3x. And then 20 over 5 is 4. So when we divide both of those terms by that 5 that's there, we actually get a simpler expression. Now there's no fraction left anymore. So this is the other thing that we can try. So simplifying expressions, those are the three things we could do. Distribute, combine like terms, or divide. And sometimes you'll have to do multiple things in one example. So let's look at a couple examples real quick and look at this in problems that you're going to have to do. Determine if the two expressions listed are equivalent. Must show work to justify your answer. So we've done things like this before where we've had to distribute and combine like terms to show equivalency. So remember, equivalent just means are they actually equal to each other? So the first thing that we're going to do here is we can look and see that there's parentheses. In order to get rid of parentheses, we have to distribute whatever's in front. So in this case, we're going to distribute that -1. Since it just says minus this stuff, we know there's an invisible 1 there. So we're going to have 13 minus 2a, and then we're going to do -1 times -5. That becomes a +5. Now that we've distributed, the parentheses are gone, so now we're going to look for like terms. And we can see that we have a 13 and a 5. The -2a doesn't have any like terms, so we're just going to leave it alone, -2a. And we know that 13 plus 5 is 18. When we look at this one over here, this was 18 minus 2a. If we look at what we were able to simplify this down to, we can actually see that -2a plus 8, oops, not 8, 18. Hopefully you guys caught that before I did. Sorry about that. We can actually rewrite that. That's the same thing as 18 minus 2a. So when we look, these are the same thing. So yes, these are equivalent. All right, that one's not new. That one we've done before. Let's take a look at the next one. You'll notice that that first part there has this fraction. So if we simplify, we can simplify by dividing. So 24b over 2 minus 12 over 2. 24 over 2 is 12, so we have 12b, and then 12 over 2 is 6. So we have 12b minus 6. This expression up here simplifies down to 12b minus 6. Now we need to look at this one, and this one actually isn't simplified yet either. So we're going to need to simplify that expression also. We can see that there's parentheses, and we know that the way to get rid of parentheses is to distribute. So we're going to take that 3 and multiply it inside. So we're going to do 3 times 4b, which is 12b, and 3 times -2, which is -6. So we get 12b minus 6. That's the same as this expression, which means yes, these are equivalent also. All right, so we have one more thing that we need to review in your notes, and that is graphing these functions. We've done this before, all right? All of Module 2 was on graphing lines, and then we did it a little bit in Module 3 also. So we're going to really quickly run through this. So we can tell that these are lines because there's no exponents, right? We've got our x and our y. And if we look here, there are two things you should be able to pull out. There are two key features. The first thing is your slope, which we know we use m for slope. The slope is the number that's being multiplied in front. So that's that 1/2. Then the other thing that we can always get from our equation is our starting point. So remember, whatever's inside the parentheses with the x is going to be the starting x value, and whatever's outside at the end is going to be your starting y value. The thing you have to remember is that we're always going to take the opposite of what's inside the parentheses though. So our starting point is going to be a positive 4, negative 7. And that was again because we took the opposite of what's in here for our starting x, and then this was our starting y value. And if you want, remember we always used to make that little table, right? So if this is 4, that's why it's x minus 4 inside, and then this was negative 7, that was our starting y value. So now we're going to actually do that. So find the point for negative 7. So this is my x value and my y value. That means I have an x value of 4, 1, 2, 3, 4, and then negative 7 means go down 7. 1, 2, 3, 4, 5, 6, 7. So that's right here. And now we're going to use our slope of 1/2. So I'm going to go over here and just write this really quick. Slope of 1/2. Remember, your slope is your rise over run. A positive 1 means go up 1, and a positive 2 means go right 2. So from this point, we're going to go up 1 and right 2. Up 1 and right 2. And then I'm stuck. I can't go anymore. But remember, you can always go the other way. So go back to your starting point and do the opposite now. Instead of going up, go down 1. And instead of going right, move to the left 1, 2. And then do it again. Down 1, left 2. Down 1, left 2. And there's our line. So we're actually going to use a ruler and draw it through. We get a nice straight line, and we have to remember to put arrows on our lines because it goes on for forever. One more example. So we have y equals negative 3x plus 6. Again, there's two things we can figure out. We can figure out the slope, and we can figure out the starting point. So remember, the slope is the number in front of the x, so our slope in this case is negative 3. And if it's a whole number, we can write it as a fraction. We can write it over 1, so negative 3 over 1. And in this case, our starting point, there's nothing with the x value, which means our starting x value is 0, and our starting y value is this 6. That's that y-intercept that we talked about. So our starting point is 0, 6. So 1, 2, 3, 4, 5, 6. So we're going to find 6 on the y-axis. And we're going to use this slope of negative 3 over 1. Remember, rise over run. So if it's a negative 3, that means we're going to go down 3, and we're going to go to the right 1. So down 1, 2, 3, right 1. 1, 2, 3, right 1. And keep going. 1, 2, 3, right 1. 1, 2, 3, right 1. So I'm stuck over there. Now what if I go the other way? So up 1, 2, 3, and left 1. So I can get one more point at least. And now I can draw my line through. Again, make sure you use your straight edge and draw arrows on your line so that you show it's going on for forever. If you had any questions, please make sure you wrote them down. I will answer any of them before you guys actually get started on your practice. I'll see you tomorrow. Thanks for watching.